This is one of the important topic in engineering mechanics, and name of this topic is trusses. It is also called frames. So in this session we will try to basically first understand what are the trusses and what are the important concept about a trusses. Particularly in this session I will more focus about the theoretical aspect of a trusses and the solution methodology. However, we are also going to solve a numerical problem, but primarily the objective of this session is to understand the trusses, as well as I am also going to discuss that the stability of the trusses, because these are the structures and it is very important as an engineer that you should understand that when you make a structure like trusses, whether the structure will be stable against the forces or it will behave as an unstable structure. So we will try to see some of the part of the stability and instability of the truss, as well as we will try to see how we can identify this stable and unstable behavior. At the same time, we will also see the representation of the internal forces, because this representation we are going to follow throughout the solution of the trusses problems. So I will start that with the definition of the truss, that what is a truss. So truss is a structure basically which is made by joining the small members. So we can see trusses when we go outside. Particularly I am showing two pictures here, and here you can see that when we go outside we see such zigzag type of structure which is made by the combination of small members. And we can see this sort of structure when we see outside the bridges, as well as the other example of that when we see the long high towers which are used to carry the electric transmissions line. These towers are also made by these kind of joining of the members, and this is also an example of truss. This is also an example of truss, but the basic difference in these two is that here the members are moving in all the three dimensions, so we consider that this is a three-dimensional truss. However, if we will see here, in one part all the members can be considered in a single plane. So when we will solve this problem, we can consider that this is a planar truss or a two-dimensional truss. And when we see carefully, we can see here that these two ends are supported on the ground. However, all the other portion of the truss is hanged in the air, and when someone pass over this bridge, or a train or a vehicle pass over this bridge, there will be loading on the truss members. And basic objective of the truss is to bear the load and distribute the load among all the members, and ultimately the forces reach to the support reactions. So if I'll remove, or I'll take this individual member as a separate truss, I can see and I can understand the different components of a truss. This is the diagram of this one part, where I can see here that these are the two supports. So here I am showing two supports, one support and the second support. These are the members of our truss which are connected here with the pin joints. You should understand that when we make the truss, the joints are considered as the pin joint, and these are the two supports, these are the members, and here I am showing 3 points where I am considering the loading on the truss. So this is one of the example of my truss. Similarly, I can see other types of truss. Here I am showing two types of truss. You can see here that in the first diagram I am showing that these are the members 1, 2, 3, 4, 5 and 6 member are connected to each other with the pin joints and the two support, and there are two loading. So here the structure is cantilevered kind of structure, so these kind of trusses are basically considered as the cantilevered truss. Here I am showing second example. Here there are 1, 2, 3, 4, 5, 6, 7 members connected with the 5 joints, and there are 3 forces. Force may be more than 3. And there are two supports. So these sort of trusses are considered basically simply supported trusses. If you will see the example of this bridge made by the truss, here also the truss is supported with the two ends, so I can say that this is my simply supported truss. However, if we see one of the arm of this tower, we can consider that this truss is in the air and the other part of the truss is supported to the main body. So this part can be considered as a cantilever truss. However, this is a three-dimensional truss, and our main focus in this session will be a two-dimensional or planar truss. Now, once we have understood that these sort of structures are trusses, then what is the job of an engineer? What is the job of a designer is to design a truss, and when we design the truss, we basically design the truss again a given load condition. Suppose we are making a bridge, so we know that this much amount of load is going to be on the bridge, and on basis of that we have to design our truss. When we have to design a truss, that means we have to calculate the dimensions of our members or the size of our member, and that can be calculated only when we know the force in the member. Now you should understand that there are three forces acting on this truss. It doesn't mean that all the members are having the equal forces, and as well as the nature of forces is also important. What I mean to say nature of forces, that some of the member is experiencing a compressive force and some of the members are experiencing the tensile force. So we will try to understand that how to find the nature of the forces as well as the magnitude of the forces. But we should understand that all the truss member are basically connected to the two pin joints, and if we are connecting a body with the two ends with the pin joints, that means there will be forces at the end, there will not be any moment at the end. And the forces, if we have to satisfy the necessary condition of equilibrium of this individual member, the forces should passes through the axis of the member. Why? Because if there's a basic law that if a body has to be in the equilibrium and only because of the two forces, or I am subjecting two forces and I want to be my body in equilibrium, that means the two forces should be collinear forces. Here also the body will be subjected with the two ends and there will be only forces, there will not be any movement. That means it is an essential condition that the forces at the two ends will be collinear to each other. However, the nature of force may be going in this way or going in this way. That means if this sort of force is acting on the member, the force generated in the member will be of compressive nature. If this sort of a forces is acting on the member because of the configuration of my external forces, the nature of the force in the member will be of tensile nature. This is the external force. Now I am going to show you the internal force, but before I show the internal force, you should understand that the truss members are basically a two force member. This is an important question and generally it has been asked in the interview also, that what is a two force member. So we should know that the two force member is a member which generally used in the trusses, and it can be subjected only axial forces, maybe the compressive or maybe of the tensile nature. So the job of the designer is to find the nature as well as the magnitude of force, and the nature may be of compressive or maybe of tensile nature. Here I am showing two members, and you should understand that here I am showing two arrows going towards the member. The two arrow is going towards the member, and these I am showing this is the external force. This is my external force. So what will happen if the member will sustain or will not change its shape? That means it is producing an equal and opposite force, and to sustain or to remain in this condition, the member will produce a force which is having in this way. So this is the external force and this is the internal force. But we can see here that the forces are going in this way, that means the member will be in the compression, but when we'll see the internal force is going in this way, away. So if I am having a member and I am showing internal force in this way, that means the nature of the force will be compressive. On the other hand, if the external forces are acting in this way, the internal force will be generated going inside, and the nature of the force will be tensile here. So we should keep it in mind, and I will repeat it again, that how we design or how we represent the forces in the truss member, basically the internal forces in the truss member. But before that, let's discuss one of the important concept of truss. So I'm coming back to my original diagram, that here is the one of the type of truss, and if I'll observe my truss carefully, I can see here one important thing, that is the members are connected in the form of triangles, not any other shape, not a parallelogram or any other shape. The question, why the members are connected in triangle? What is the motivation behind that? The second thing that we considered, that the joints should be pin joint, as well as the other important consideration when we use the trusses is that the forces will act only at the joint position. The forces will not be act on in between the joint position. These two are the basic concept of the truss, and I'm not going to discuss this part in detail because we'll see later on. Particularly at this point, I would like to highlight that why we have the member in a triangular shape, what is the motivation behind that. So let's consider two cases. In the first case, I am showing three members connected to the pin joint, the member 1, 2 and 3. In the second case, I am showing four members are connected with the pin joints. Now I am putting this truss or this structure on two support 1 and 2. Similarly, I am putting this structure on two support 1 and support 2, and I am applying a force F here. Here also I am applying force F1 and F2. Now you see, in this case, if I will apply a force, the system will remain in this position because the three members are connected in a way that there will not be any relative movement. Physically we can observe. I am going to show you the mathematical formula for this, but here first you see the physical observation that what will happen. So in this case, the three members will be in the locked condition. However, if I will see the second case, if I will apply a force here and all the joints are the pin joints, I can understand that when I will apply a force, this part will try to move, or this end will try to move. Similarly, this will also try to move, and there is no restriction or no constraint. So I can see that this will come in this way, and the system will show some movement or motion. That means this is not a stable structure, or we should say this is a mechanism basically. It is not a structure. Here it is a structure, but this is a mechanism. Therefore, we cannot make members in a form of a parallelogram, or four member cannot be connected in this way. However, if we want to make this stable, what we can do? We can add another member to our truss. So here you see that if I will add a fifth member here, then as the fifth member will come into the picture, you can now physically visualize that if I will apply two forces here, the system will not move and the system will behave like a stable structure. Now it is not a mechanism, but if you see here, this is a mechanism. And based on the study of the mechanism, we borrowed a formula from the mechanism which represent in a way of m is equal to 2j minus 3. Now m is represent the number of the members in a truss, j represent the number of pin joint in the truss. So if I will apply this formula to my truss, I can understand whether it will be stable or unstable. The stable condition would be the equal sign, or if these two sides LHS and RHS are not equal, that means the system will not be stable. It may be unstable, or it may have some different condition. We will see it. So let's first apply this formula here, that m is the number of member. If I will apply this formula here, there are three member 1, 2, 3. So my left hand side will be 3. If I will see that there are 3 joints, 1, 2, 3 joints, so my right hand side will also be 3 into 2, 6 minus 3, 3. So in this case, my LHS is balancing with the RHS value. That means the truss will be stable. However, if I will see the same formula here, there are 4 members and 4 joints. So my LHS will be 4. However, my RHS will be 4 into 2, 8 minus 3. So it will be 8 minus 3. That means it is 5. So my LHS and RHS are not same. They are different. That means the truss will not be stable. It is an unstable truss. But if I will apply the same condition here, I can see here that there are 5 members as well as joints are 4. So my LHS will be 5 and my RHS will be, joints are 4. 4 into 2 minus 3, that will be 5. So my LHS is now balancing with the RHS. So this is also a stable truss. So stable, but this is an unstable truss. We'll see it in more detail. That suppose I am having this truss and I want to apply the stability criteria for this truss. So how I can see the stability and instability in my truss? So let me explain you again that this is my basic formula which I use to find the stability and instability in my truss. But I would also like to tell you that this formula is basically derived from a fundamental formula where the formula is m is equal to 2j minus RT. This RT is nothing but the forces generated at the support reaction. support points or the total support reaction. For example, if this is my truss and I am showing there are two supports, one is the pin joint, another one is the roller joint. So how many reaction will be there? The pin joint will generate two forces, however the roller joint will generate only one force. So there will be three reaction forces, and based on the three reaction forces, generally this formula used frequently, because normally when we have a simply supported truss, one of the joint will be a roller joint and other joint will be a pin joint. So directly you can apply this formula. But if the two joints are not roller and pin joint, that time we have to consider the RT value, and the forces will not be 3, it will be a different, we will see here. So here I am showing that the actual formula is M is equal to 2J minus RT, and this formula is basically borrowed from the design of the mechanisms, where we are interested to find the degree of freedom of a mechanism. However, I am not going to discuss the degree of freedom of a mechanism here. This is our truss topic. So I am going to focus only on the stability of my truss, and then we will see one example. So now let's see that if I will apply the stability criteria for my truss, here I know that the joints are pin joint and the roller joint. So my total reaction will be 3, and I am free to apply this formula. My number of members are 7, 1, 2, 3, 4, 5, 6, 7. My number of joints are 1, 2, 3, 4, 5. So when I will apply the formula, M is 7, RHS is 10 minus 3, then RHS is balancing with the LHS. That means the truss will be a stable truss. Another important thing we should understand here, that if it is a stable truss, this system is statically determinate, means I can apply the condition of equilibrium of force balance and moment balance, and I can calculate the unknown values. Now let's see if I will alter my truss. Suppose I am making my truss in two different way. You can see here this is my original truss with 1, 2, 3, 4, 5, 6, 7 members and 1, 2, 3, 4, 5 joints. I am applying two forces here. In this case, this is a stable structure because two joints are pin joint and a roller joint. But suppose I am going to remove one of the members. Suppose I remove the top member. Now my truss will look like in this way. Now again, if I will apply the stability criteria on my truss, I know that now I am having 6 members but the joints are 5. So if I will balance the LHS and RHS condition using the M is equal to 2J minus 3 formula, because the joints are still roller and pin joints, so I can apply this formula. So I can see here that my M will be less than the 2J minus 3 value, because this is 5 into 2, 10 minus 3, so it will be 7. However, the members are 6. So when the number of members are less than this value, the truss will be this will be unstable truss. On the other hand, now you can think that how it is physically unstable. So we can see here that this joint will be prone to move and the whole system will try to rotate in this way, and truss will behave as an unstable truss. As a moment I will add one member here, it will become a stable structure. On the other hand, now here I am making second alteration of my original truss. Here is my original truss, and what I did here, instead of removing the joint which I did here, I have removed the roller support and replaced the roller support with a pin support. So now, as we have seen in the beginning, that when we having the two pin support, here we are having two pin support. So we have to apply this formula. We cannot use this formula because these 3 will not be here. Now the reaction forces will be 4, because these two joints are the pin joints. So 2 forces will come here. Similarly, 2 forces will come here. So my RT will 4 now. So when I will apply the M is equal to 2J minus RT, this will be my formulation, and members are 7 now. But when I will solve the 2J minus 4 part, I am getting that this is coming 6 value. So in this case, previously the M was less than 2J minus 3. Here M value is greater than 2J minus 3. It indicates that my number of unknowns will be more and the number of equation will be less, and the system is statically indeterminate. I am not going in the further detail of indeterminacy in our system, but you should know you should touch upon that the system may be statically indeterminate or statically determinate. Here the system is statically determinate, then these equations are sufficient to get the unknowns. But if we will see here, if the system is statically indeterminate, it will create a problem and we will not able to solve the unknowns value. However, generally it is not asked in the exam, but as an engineer you should know that how you can calculate the statically and statically indeterminate or determinate truss members. Now I will move to our problem, but before I move the problem, we should know that there are two methods which apply to solve the problem of trusses. And what we solve in the trusses, I am repeating again, we have to find the nature of the forces as well as the magnitude of the forces in different truss member, so that designer can design the size of the member. There are two methods. One is the method of joint, another is the method of section. Here I am starting with the method of joint. Slowly we will accelerate and we will also see the method of section, but in this session I am going to focus mainly on the method of section. And in my second video you can see that I am going to show you some of the important example solving through the method of joint. So now, before we solve a problem using method of joint, I would like to mention again that the truss members are basically two force members. If I am applying an external force in this way, the external force is a compressive force and the system will create an internal reaction force to remain in its original condition. So this is the effort generated by the member, and we can see that the external force trying to compress the member and the member is putting an effort equal and opposite to the external force. So these are the representation of the external force and this is the representation of the internal force. If the external force is of compressive nature, the arrow will go away for an internal member. So here if I am showing that the arrows are coming in this way, that means it is opposite. My external force will be this way and the internal force are going in this way. On the other hand, this is showing that if the external force are compressive, the internal force will be in this way. This is my tensile force, this is my compressive force. I can see here with this example also that I am having a joint, I am having one reaction. How it is coming is not important, you should understand first. There are two member with an angle theta. I am giving a force to this member which is trying to compress member MB. On the other hand, I am giving a force which is trying to pull the member AC. If I will make a free body diagram of AC and AB, I can see that the AC member will be in the tensile nature. So the internal force will be like this. On the other hand, the AB member will be in the compressive, the internal force will show in this way. And why I am showing this internal force? Because generally when we solve the problem of trusses, we represent the trusses in terms of internal forces. You can see here that if I am representing this joint A, here this is the representation of forces. This is my member AC and this is my member AB, and the member AB is in compression, so the arrow will go away, and member AC is in tension, so member will be going in toward each other. But when I will see the free body diagram of this joint only, this point only, in case of the free body diagram of point, when I will see the complete member, I can see two arrows. But when I am making the free body diagram of this point, the free body diagram of point will be considering only these two arrows. That means what is happening? If the nature of this force is compressive, the arrow will come towards the point. If the nature of force is tensile, the arrow will go away from the node. You should learn, you should understand that if I am making the free body diagram of point, if force going away, then that means it is tensile. If it is coming towards nodes, it is of compressive nature. When we will solve the problem, we will learn this, but here I am again showing one case that this is a truss and I am showing the internal forces, and I am asking you to make the free body diagram of point A, B and C. So if I will make the free body diagram of point A, here I am going to show the reaction R1. Now I have to show the member AC. So this is my member AC and this is my member AB. Now what would be the direction of member AB? As I know that these arrows are going away, that means it is a force of compressive nature. These arrows are coming inside, this is the force of tensile nature, and here also the member arrows are coming inside, that this is the tensile nature. So when I will make the free body diagram of this joint A, I am not going to see these arrows, I am going to see these arrows. So I am going to consider these three conditions for my free body diagram. So that means this is my force F AB and this is my force F AC. Similarly, when I will make the free body diagram of joint C having one force in this way, another force in this way, another force in this way, this is my reaction R2. So this is a tensile force, this is also a tensile force, this is a tensile force, and this is a compressive force, and this force will be written as F BC and this force will be written as 4 AC. Similarly, if I'll make the free body diagram of joint B, there are two forces going away and one force which is an external force F, and this will be of AB and FBC, and this force is going in this way. So when I will see the whole system, I can see that this part is continuation of this line. So the two forces are going away and this part is continuation of this line, so these are coming towards to each other. So this is my complete member will be like that. I have made the diagram here, but this is basically my complete member and this is my complete member. So now without any delay, let's solve one problem. That here I am showing a problem of truss. This is a truss made by 5 members, 1 2 3 4 5. There are 4 joints, 1 2 3 and 4, and a force of 400 Newton is acting at point C. Here the angles are given that the bar BC or member BC making an angle 45 degree from the vertical, and this diagonal member BD is making an angle 30 degree. This member is also making a 45 degree, and all the distances are given. This is 2, here also 2, and here also 2. Basically the force is passing through this point. And what is asked? It has been asked to find the forces in all the members. So now before I solve the problem, as I have already explained you that the forces may be the tensile nature of the compressive nature, but to solve the problem, let's fix some rules. My first rule will be that, and this is very essential condition, that I can solve the problem only if I can consider a joint with maximum 2 unknowns. Why I have to consider 2 unknowns? Because let me explain you that ultimately what we are going to do, we are going to make the free body diagram of individual point. So if we are going to make the free body diagram of a point, basically we are going to write the equation of equilibrium of a particle. And we know that when we are having a particle subjected to number of forces, we can basically write two equations. One is the equation for the summation of horizontal forces, one is the equation for summation of vertical equation. So basically we are going to write two equations, so maximum 2 unknown can be solved with one free body diagram. So this is an important and essential condition which said that we can start our problem with a joint where we are having maximum 2 unknowns. If the unknowns are more than 2, we cannot solve the problem. For example, if I want to start my problem with joint D, so if I'll make the free body diagram of joint D will having 3 forces. And second assumptions which I generally considered in my cases is that I am going to take that the forces will be of tensile nature. That means whenever I will make a free body diagram, I will consider the forces going away from my node. However, when I will solve the problem mathematically, it may be possible that the answer will be negative, and I will correct that if the answer is negative, that means the force I have considered is actually of compressive nature. But I can start the problem by considering the forces as of tensile nature. So when I am having this problem, my job is to first make the free body diagram of all the 4 points. So if I will make the free body diagram of all the 4 points, I can make that this is my pin joint and this is my roller joint. So suppose I will start the free body diagram of point B. There will be 2 forces, 2 reacting forces, and there will be 3 forces, one going to this point, second going towards this point, and third going towards this point. So now I am having By, Bx. This is my force which is going towards point C, so it is my BC force. This is my force which is going towards BD, and this is my force going towards BA. This is the first diagram of joint B. Similarly, if I will make the free body diagram of joint A, here I can show that this is the reacting force and the only one reaction because it is a roller joint. I am having a force which is in this member. From B I have made a force going towards this direction. So at the same time, I am assuming the force in this member is of tensile nature. So when I am making this point, I am showing an arrow in this direction. When I am going to make this point, I am going to show arrow in this direction. So this will be my force F. I can write it AB or BA, and the nature of the force will be tensile. Similarly, I am going to make one arrow here which is showing the force FAD, and the nature of force here also tensile. Since these are unknown values, so I can take any direction. If you want to make the force towards this direction, it is okay. When you will solve the problem, if your answer is positive, that means you have considered a correct direction. Otherwise, you have to consider that the nature of the force will be of opposite. So when I will make the free body diagram of D, there will be 3 forces in this way. And similarly, when I will make the free body diagram of C, there will be 1 force here, 1 force here, and 1 force here. So now, what is my first assumption? My first assumption is that, or my first condition is that I can start from a joint where I have maximum two unknowns. So let's analyze here. If I'll start to solve the I'll start to write the equation of equilibrium for my point B, I can see here that there will be 1, 2, 3, 4, 5 unknowns. So no, I cannot start from here. If I'll try to start from point A, there are 3 unknowns. If I'll try to start at C, there are one unknown which is FCD, another unknown FBC, and a known force 400. Yes, this is the point from where I can start. So if I'll start solving problem here, first I will calculate these two unknowns by writing the equation of horizontal and vertical force balance. Once I will be ready with these two forces, either I can move here or here, because if I will know FCD, I'll go and solve the free body diagram of joint D. So this will be known for me in that case, and these two will be unknown. And similar way, I can sequentially move and I can solve all the points to get the unknown of all the points. So now let's start the problem. First I'll consider the equilibrium of joint C. Here I'm showing the free body diagram of joint C, where there are two forces along this direction and one is known value. This is the free body diagram of joint D, where there will be three forces. This is the free body diagram of joint P, and this is the free body diagram of joint A. And let's start our problem with the point C. So now, as I am solving my problem for point C, you know that once I have the free body diagram of a point, the next job is to write the equation of the force balance, and I am writing the equation for the horizontal force balance and the vertical force balance. So when I will write the equation for the horizontal force balance, here is my equation, that FCD, which is, if I am assuming that this is my positive direction and upward is my positive, so FCD will be positive, and the horizontal component of BC, that will be FBC cos 45, because the angle is given here. This is 45 degree, and this angle will also be 45 degree. This is 45 degree and this angle will also be 45 degree. So now this is my horizontal force balance equation. When I will write the vertical force balance, 400 is going in the downward direction, so minus 400. Similarly, the vertical component of force BC will also going in the downward side, so minus 400 minus BC sine 45. So from these two equations, I can get the value of force BC as well as force CD, and here you can see both the forces are coming negative. That means the nature of the forces in these members will be of compressive. However, I have considered the forces going away, or I have considered the tensile force, but the answer is negative, indicating that the nature of the force will be of compressive. No problem. Finally, we will write all the forces, but as I have considered the tensile force, I'll keep going with the tensile force with the negative sign. So now I have calculated force BC and CD. Now I will move to the joint D. So here is my joint D. So this is my joint D. Again, I know that CD I have calculated with minus 400 magnitude, but the arrow is showing away. That means it's a tensile. These are the two unknown. Again, I will write the equation for horizontal and vertical force balance, and you see here that the angles will be 30 degree and 45 degree. So you can see here that this is 30 degree, so this angle will also be 30 degree. And this is 45 degrees, so this angle will be 45 degree. So the angle vertical will be 45 and this angle will be of 30 degree. Balance. This is the equation for my horizontal force balance minus CD, because this is my negative and this is my positive direction. Upward is positive and downward is negative. So minus FCD, horizontal component of these two forces will also be in this direction. So all the forces will be with the negative sign. FBD cos 30 and FAD cos 45 or sine 45. So this is my equation for the horizontal force balance, and this is my equation for the vertical force balance. When I will put the value of FCD, which I have calculated in the previous free body diagram, I am getting the FAD is coming out minus 773. Again the minus sign. Please understand. This minus sign, that means the FAD force, which I am showing as a tensile force, will be actually a compressive force. And this is my second force, which is my FBD, and BD is coming out 1092.8, but the positive sign, that means this force will be of tensile nature. Now I have calculated two more forces. So in my diagram, I have calculated this force, this force, this force, this force, and this force. The only unknown is this force, which I can calculate it by making the free body diagram of my joint A. So here is the free body diagram of joint A. And when I will solve the vertical force balance, I can calculate the force this is my force FAD. AD is calculated here already, so I am going to calculate force BD, and AB is coming out basically minus 544 Newton. That means again this is of compressive nature. So once I have calculated all the forces, I can show all the forces on my original truss. So suppose this is my original truss. Again I am going to make my truss in this way, and I know that there will be two reaction which is known to me. This is one reaction, and now let's start making all the forces. A, this is A, this is B, this is C, and this is D. And I know that my forces are, my first force I calculated CD force. CD as BC is minus 400. So this is my BC force. So actually the force BC will be of compressive nature. So compressive nature means this will be shown this way, and the magnitude of FBC will be 400 root 2. Similarly, FCD is also, CD is of compressive nature, so this will be my compressive force, and the force magnitude is 400. The third force which I have calculated is the AD force. AD is also minus, AD is here, so it will be also minus, and this will be in this way. But BD is positive, BD is positive, that means the nature of the force will be in this way. The arrow will go inside, however all the three arrows is going outside from the center of the bar. The last force which I have calculated is AB, and which is also minus sign. So here also I am having a force which is going in this way. So finally I have calculated all the forces in all the member. I have already identified the nature of the forces. So based on that we can solve different problem of trusses, which we will see in our next video. Thank you.